Okay, let's have a look at exercise 15.06, question 39. And we've got a couple of things to reconcile here. We've got an x to the 8, which looks a little nasty, and a y to the 4. Fortunately, though, we can get around this. What we can do is we can say, let's let a is equal to x to the 4. And let's let b equal y squared. So every time I see an x to the 8, that's just going to be a squared. In other words, x to the 4 squared, which is x to the 8. So here's x to the 8. If I put an a, that's automatically x to the 4. If I square it, that's now x to the 8 plus 4, and I've got x to the 4, which is just a. Y squared is just b plus 4 y to the 4, which is just b squared. So now I've got something that I can reasonably work with. Well, let's try that. So I'm just going to deal with the a's to start with. Now, obviously, we've got what we had before, the perfect square. So it's going to be a plus something and b. So a plus b times a plus b. Well, let's see how this plays out. We know that a times a is a squared, but b times b is not 4b squared. So I need to make that a 2b and a 2b. So now let's try that. A times a is a squared. 2b times 2b is 4 squared. And 2ba plus 2ba is 4ab. So that works. So all we've got to do now, and that's correct, is every time we see an a, we've got to revert back. So I've got an a, well, that's an x to the 4. So I've got x to the 4 plus 2 times b, well, b is y squared. And I've got the same thing all again, so it must all be squared as part of our perfect square. And there is our solution.